All right, gang, here we go. So this is Chem 1, Unit 3, and this is Chapter 5, Part 1. So we just finished up talking about electrons, electron configuration, so on and so forth, and now we're moving on to the periodic table. So this is the second half of our Unit 3, where we're talking all about the periodic table, some of the trends that we see, where it comes from, why it's called the periodic table, and lots of other fun things to do with it. All right, so here we go. This guy here, Dmitry Mendeleev, all right, it was the first guy that developed a periodic table. Okay, now he wasn't the first one that tried to arrange the elements. Okay, he was the first one that to develop what he called the periodic table. So what he did is he took all the elements and he arranged them according to their atomic mass. Now you might be asking yourself, why didn't he use atomic number, the protons, right? Well, the answer is he didn't know. They didn't know about protons when he was alive. They weren't discovered until after he was dead, and so he used atomic mass, and those were a known quantity at that time, but. So anyway, so he took atomic mass. Now that's not in and of itself isn't very interesting. He wasn't even the first one to arrange them based on atomic mass. What is interesting is that once he arranged them in order of increasing atomic mass, he then put them into groups based on their chemical properties. Okay, so he would group up these things, and he realized that he'd get these periodic trends that as he arranged them based on their properties in groups and then put them in their atomic mass, he realized that he'd start to have these recurring properties, and so he called them periodic. So think about this term periodic. Periodic means that it appears every once in a while, right, or appears every so often. So we say like the phases of the moon are periodic. They cycle every month. So on and so forth. Okay, so he called the periodic table periodic because the properties appeared periodically. Okay, and so that was actually quite the breakthrough that he arranged it based on, because people had arranged it based on properties and people had arranged them based on mass, but combining those two is really kind of a step in a really new direction. Not only that, but he predicted completely new elements that hadn't been discovered yet. And so here's an example of some of the ones he came up with. So like echo aluminum was one of the ones that he hypothesized existed. Now this in itself was another huge breakthrough that Mendeleev kind of formatted or came up with, was this idea that there were elements that hadn't been discovered yet. So he predicted, not only did he predict that they existed, but he predicted their properties eerily accurately. Okay, so like for example, echo aluminum. So he thought like right below aluminum there had to be another element that existed that hadn't been discovered yet, and it was discovered in 1875. And he predicted that its density would be 6.0 grams per milliliter, and the exact was actually 5.96. And he predicted its melting point would be really low, and the observed property was 30 degrees, right? It's Celsius for melting point, which is actually pretty low. He even was able to predict what kind of oxides they'd make, so how many of them would pair up with the oxygen. So this idea of predicting elements that hadn't been discovered and being able to identify their properties was a huge deal. In fact, there were several times where other chemists would say they discovered a new element and give their properties, and he would call them out and say, no, that can't be right, you did something wrong because my predicted property doesn't match your discovered property. And so he'd like call people out on it. So he's very confident in his abilities, and it was pretty good. Anyway, so that's Mendeleev. Then several years later, along came Henry Moseley. And Henry Moseley was the guy that said, well, atomic mass, that works pretty good. But what if we used atomic number? And now we know, that atomic number is the number of protons, right? So this is the number of protons. So this is essentially what we use now. So Henry Moseley kind of put together the periodic table based on atomic number. And so there were several instances that this kind of changed things up. Most notable example is between cobalt and nickel. Okay, cobalt has a higher mass. Cobalt is element number, let me see, I can't remember. Cobalt is element number 27, okay, and nickel is element number 28, but cobalt's average atomic mass is 58.93, and nickel's is 58.69. Okay, So even though nickel has one more proton, it actually weighs less on average than cobalt. So there were a couple places on the periodic table where that kind of transition happened because of changing between atomic number and atomic mass. But anyway, so then we get this idea of the periodic law. This is very important. All right, periodic law. And essentially what it means is when we arrange the elements according to their atomic number and put them in groups based on those, we get a repetition in their physical and chemical properties. Okay, and so elements that have similar properties fall in the same group. All right. So remember, so here's a picture of Mendeleev's periodic table. So it's kind of nuts, right? Like, what the is going on? Anyway, so on our periodic table, remember, we've talked about this before, but these are the groups, right? Groups are the columns, okay? And then the rows are the periods, all right? Periods. All right, so you remember, like if you're like looking at a group of people and you're like, and you are in a group, and that's period. You're in a group, period, right? So anyway, so you can divide them by group and period, group, period. All right, so groups are the columns, periods are the rows. So the groups tell us the what similar physical and chemical properties they have. All right. So let's see, what else can we do here? So we've talked about several of these things before. So we know that there's like an imaginary stair-step line that kind of goes like this. All right, more or less like that. And we know that these guys here on our imaginary stair-step line, let me just make sure I'm shading in the right ones. Okay, here and here. Okay, and these guys, so these guys are metalloids, right? The ones on either side of the stair-step line, right? Metalloids. Okay, to the right of that are the nonmetals. Okay, and then everything else are the metals. Okay, all right, so you got your metalloids, your nonmetals to the right, and your metals to the left of that. Okay, so everything else is a metal. Okay, so here's some properties. We've talked about this before, so I'm not going to spend a lot of time talking about this. Just pause the video and take notes, and go back to a previous video if you want to see me talk about that. Anyway, so here we go. So different groups that you need to know on our periodic table. Group 1A, so that's the very first column, are known as the alkali metals. They're very, very reactive, and I'll show you some of these in class. It's pretty fun. Okay, and they're not found in nature by themselves. Okay, we have to isolate them in the lab, okay, by chemical processes, and they're so reactive that they'll actually react with water just in the air. And so once we have them isolated, in order to store them, we have to keep them in oil so that the water doesn't react with them, okay, because water and oil doesn't mix, right? So you'll see that, you know, it keeps it in an oil so they don't react. But so we don't actually see these in nature. Okay, the group 2A is the alkaline earth metals. Well, so let's talk about this. So alkali metals, this is like lithium and sodium and potassium, etc. Okay, rubidium, cesium, etc. All right, alkaline earth metals are the groups right next to the alkali metals. So this is like beryllium, magnesium, calcium, etc. Okay, so down that column. Okay, they're still pretty reactive, but not nearly as reactive as group 1A. All right, and they're still not really found free in nature. You'll find magnesium, like magnesium oxides, calcium ions, you know, but you don't really find those metals just chilling in nature. Once again, we kind of have to isolate those in lab. But once you isolate them, and if you keep them in a sealed container, they usually stay pretty good. Okay, group 7A, so this is the group all the way down on the right side of the periodic table. So these are these guys here. So if we were just going to label these, this would be 1A, this is 2A, all right, 3A, 4A, 5A, 6A, 6A, 7A, 7A, and 8A. All right, so 7A, these guys here, this is the halogens. Okay, the halogens, and they're very reactive. In fact, they're the most reactive nonmetals. So remember, the nonmetals are the ones to the right side of the stair-step line, and they're the most reactive nonmetals, and they form salts. All right, so and a salt is defined as a metal with a nonmetal. Okay, metal with a nonmetal. And then finally, a group A non-noble are the noble gases. And so that's the very last column. These are inert gases. Inert meaning that they don't react. Okay, they don't react. So they're called noble gases because they kind of chill there in the last column, and they're noble, like like the nobles back in the middle ages would be like, oh, we don't participate with those peasants. They can rabble rouse amongst themselves, but us nobles, we're above the fray, kind of thing. All right. And then so you've got these different areas of the periodic table. All right. The representative elements are these groups 1 through 7A. All right. And then you have the transition metals is the middle block, and we've talked about this. This is the D subblock, or the little area that's down below. And then the inner transition metals are the extra 2 rows that oftentimes appear in the bottom of a periodic table, the F sublevels, right? The F block. Okay. Yeah. So just to label some of these guys, so remember, so we've got 1A and 2A, and then 3A, 4A, 5A, 6A, 7A, and 8A. So these guys are, the A's are the representative elements. So this guy here, this is the D block, these are the transition metals. Okay. Okay, and then these guys down here are the inner transition metals. Okay, inner. All right, and remember, these guys fit in right here. So remember when we talked about electron configurations, you would go down here, 6s2, and then you jump down to 4d, or 4f, excuse me. All right, so that's it for this video. Nice, short, and sweet. In the next video, we'll talk about periodic trends, so make sure you pay attention when you're watching that one, because it's a doozy. Anyway, do practice problems. Let me know if you have any questions.